Hi everyone. So today I saw a video on Monte Carlo method and it was shown how we can calculate the value of pi using this method. And I was so fascinated by that I thought, why don't I write my own code and see what exactly happens here. So this is me just sharing my excitement with you. So let me show you what I exactly did. So in Monte Carlo method, for example, if there is an event whose outcome is unpredictable or it's very random, so what Monte Carlo method says is that we can try to repeat that event 10 times, 100 times, or lakh or n number of times. And then from the output of that particular event, we can try to derive a distribution and make our conclusions based on that. So for calculating the value of pi, let's suppose that we have a rectangle in this first quadrant of xy axis, and this is 80 on x axis, this is 50 on y axis. Now let's suppose that we try to drop a ball on this board, this 50, 80 board. So we won't be able to exactly say where the ball goes. For example, if I just close my eye and try to make a point here, or anywhere, I won't be exactly able to tell what are the coordinates of this point. So this is an event where the output is random. Now to calculate value of pi, what we can do is, if we make a square in this board and we make a circle such that the side of square is equal to the radius of circle, and let that be 10. This is the value that I've taken in my code. So as we so now let's try to get the probability of a ball falling or the point being inside the circle or the square. Under the constraints of this particular rectangle, the probability of the ball being inside the square or of the rectangle will be directly proportional to the surface area of this square or of this circle. Now, so the probability of circle will be directly proportional to pi a square, where a is the radius of the circle, and probability of the square will be directly proportional to a square. Now, if we take the ratio of PC by PS, it will basically be equal to pi a square by a square, and like this is a basic mathematics, we can cancel out a square. Now this will be equal to pi. So if we try to repeat this event, if we keep on repeating this event many times, then the probability of PC by PS will approach to pi. Now in a way we can say that the probability, we can calculate the probability by the number of balls that are inside this square or the number of balls that are inside this circle. So this is exactly what I've done here. I try to find out a random coordinate, that is x comma y, using a random function in Python, and that random number will be between 0 to 80 for x and 50 to 0 or 0 to 50 for y. Now if it falls inside the square, like I increase the number of balls that are inside the square for that particular iteration, and if it falls inside the circle, then the number of balls inside the circle will increase. And for example, if there are 100 balls at a moment, out of which 20 are inside the circle, 10 is inside the square, and the rest 70 fell elsewhere. So 20 by 10, this is the ratio that we are looking for. And as we try to increase this 100, for example, if we go to 1000, if we go to a lakh, if we go to 10 lakh, then this ratio must tend to pi. This is what happens theoretically. So let's go to the code and see what is happening. So this is a basic setup. The radius is 10, A, the side of circle is 10, center of circle is 50, 25. It can be any random thing until and unless it is inside that rectangle. The X maximum board, Y maximum board, 50, 80. This is the dimensions of the square. Now for every simulation, like I said, I generate a random coordinate x comma y, and this random coordinate must be within the constraints of 80 comma 50, that is the constraints of the board. So after getting the random coordinate, I see if this coordinate falls inside the circle or inside the square. This particular thing is, for square it's quite simple, and that the value of x must be between 10 to 20 and the value of y must be between 10 to 20. This is very simple. And for circle, to know if a point is inside the circle, the distance from the center of the circle must be less than or equal to its radius. So if this criteria is met, that means the point is inside the circle. So this is exactly what I do here. If distance from the center of the circle is greater than its radius, then we return false. So if the point is inside circle, the number of balls inside the circle is increased. If it is inside square, the number of balls inside the square is increased. This is just a data to store it in a JSON. And if this thing we will have to apply a zero value check, that if the balls inside square is 0, for example, if we have just dropped one ball and it fell inside the circle or the square, then the ratio that we'll be calculating is 0 by 0, and then this computer will get angry. So if it is 0, then if it is not equal to 0, then we calculate the ratio, else the ratio is kept as 0. So let me just try to simulate this for 100 number of times. So we can see that the current ratio just approached to 1, and now if I increase this to 1000, you can see it has increased to 2.8333. Now let me increase this to 10,000. Now it has gone to 3.49578, whatever. Now this is a lakh. Okay, so after a lot of calculation, it came to 3.074. And if we go to 10 lakh, this might take not a lot of time, like 10 seconds maybe. We can see that 3.146, 3.15, 3.16, 3.17. This is the value. So the last value that we got is 3.1686. So I have made the graph from the previous simulation that I had run, and this is the simulation for 10,000. So there is a lot of bouncing on there is a lot of vibration on the earlier part for the earlier iterations, but we can see that it slowly approaches to pi at this point and then at this point. This is for 10,000 runs. This is for 1 lakh runs, and we can see that it has already approached the value of pi, and this is for 10 lakh. If we try to make this, the graph that these 3 graphs that I made it on data1.json. This is the current data. So let me show you. the graph for this. So for, let us say, first 100 runs, this is the result for first 100 runs, and it's pretty awful. So now the result for, let's say, first 10,000. Now we can see that it has approached the value of pi a lot of times. Let's make it for the full 10 lakh. So this is the result that we got, and this seems to be pretty good from the ones that I got previously. So yeah, this is the fun thing that I saw today, and I thought it would be nice if I share this. You can find this whole code in my GitHub repository, and I'll share that link in the description. Thank you.